The James Webb Space Telescope continues to make groundbreaking discoveries that challenge our understanding of the cosmos. Now, the first real evidence of another universe has been confirmed. Startling new objects may prove the existence of other dimensions and worlds. At NASA, there is still uncertainty about the implications of the latest discoveries and whether cosmology will now have to be changed once and for all. The James Webb Space Telescope sees more sharply and precisely into space than any other telescope before it. With its 16 golden observation mirrors, this telescope can see even at angles that remained hidden from Hubble. For the first time, we're witnessing the events shortly after the Big Bang. We see strange points of light in the early universe, mysterious gaps in the cosmic background radiation, and black holes that are so huge that they must have existed before the Big Bang, or come from another universe. 1. Unexpectedly finished galaxies shortly after the Big Bang. One of the biggest surprises of the JWST was the discovery of fully formed galaxies at a time when, according to previous models, they should have been chaotic gas clouds. According to the standard model of cosmology, it took several 100 million years for the first stable galaxies to form from the dense, hot plasma of the early universe. But the JWST has found dozens of massive, ordered galaxies that already existed 300 to 400 million years after the Big Bang. Not only is the mere existence of these galaxies a miracle, but they also exhibit completely unexpected properties. These galaxies are not only much older, but also much more structured than the cosmological model allows. Some researchers therefore speculate that these structures could be material remnants from an earlier universe. This discovery gives impetus to a theory proposed by British researcher Sir Roger Penrose. Penrose published his idea of the conformal cyclic cosmology, or CCC for short, back in 2015. According to this, our universe is just one in an uncountable series. When one universe dies, a new one is born, which expands and develops until it reaches an end, collapses, and gives birth to a new universe. It may be that not all structures are lost at the end of the universe. Certain density fluctuations or even complete structures of matter could be transferred to the new universe. This would explain why galaxies in our universe have evolved much faster than researchers originally thought. 2. Mysterious Hawking points. The JWST was not actually built to map the background radiation, but here too, researchers have now used the new telescope to solve an old mystery. They use the JWST's incredible sensitivity and infrared vision to examine irregularities in the background radiation. The telescope's keen eye should reveal structures in the early universe that shouldn't be there. Such structures include larger gaps, irregularities, and colder regions. The JWST will turn its eyes precisely where such structures originated. The cosmic background radiation is the oldest light we can see, a faint afterglow of the Big Bang that has permeated the universe for around 13.8 billion years. Satellites such as COBE, WMAP, and Planck have mapped it in detail and already discovered surprising anomalies. Among the strangest phenomena are circular temperature patterns that do not fit into the standard model of cosmology. Once again, it's the researcher Sir Roger Penrose who believes he has found an explanation. The patterns could be so-called Hawking points, the remnants of supermassive black holes that existed in an earlier universe and evaporated at its end through Hawking radiation. His theory of conformal cyclic cosmology states that at the end of each cycle, all black holes slowly evaporate through Hawking radiation until only a nearly empty space-time remains. This, in turn, forms the basis for a new universe. If this theory is correct, then Hawking points in the CMB could be the last signatures of a long-gone universe. If Penrose is right, it would turn our entire worldview upside down. The Big Bang would then not be the beginning of everything, but only another phase in a much larger, eternal cycle of universes. 3. Supermassive black holes, relics from an earlier universe? It seems that the JWST has found a whole range of evidence for Penrose's theories. In addition to the mysterious Hawking points in the cosmic background radiation, there is another, possibly even more spectacular discovery that could prove the existence of an earlier universe. In its deep dives into the universe's past, the James Webb Space Telescope has found evidence that huge black holes already existed shortly after the Big Bang. This is actually just as impossible as the highly evolved galaxies. Supermassive black holes also normally take billions of years to grow to such sizes. Black holes usually form from collapsing stars or through the slow accretion of gas over millions or even billions of years. But the JWST has discovered supermassive black holes that must have existed just a few 100 million years after the Big Bang. This discovery challenges previous models, since it should be impossible for such huge objects to form in such a short time. If Roger Penrose's theory is correct, and our universe is indeed cyclical, then some of these gigantic black holes could have survived the transition between two universes. In the final stages of an old universe, when only black holes remain, some extremely massive specimens could have survived. Another clue that these black holes are old and not new is that they have fully formed accretion disks, meaning that these giants are actively devouring matter. But how can this be in a universe that should contain very little stars and matter at this epoch? Another possible scenario would be that we are looking at the interface of several universes in this epoch. It would then not only be a matter of a predecessor and a successor universe, but of an encounter between several universes of different ages. Researchers assume that universes from different dimensions can overlap regionally in time and space. 4. The mysterious cold spot, a clue to another universe? Let's take another look at the cosmic background radiation. Here, the so-called cold spot is possibly another important clue. This huge region, which is colder than calculations of the standard model of cosmology allow, could be a point of contact with another universe. Slight temperature variations are normal within the cosmic background radiation. They result from quantum fluctuations of the early universe. However, the area that scientists call the cold spot is unusually large and too cold to be explained by such fluctuations. Scientists have long searched for an explanation, but no conventional theory can fully explain this anomaly. One of the most intriguing hypotheses is that this cold spot could be the first direct indication of a collision with another universe. This would confirm the theory of the multiverse, which states that our universe does not exist in isolation, but is part of a much larger cosmic web in which there may be many other universes with their own natural laws and physical quantities. It's conceivable that there are universes in which time runs backwards, those that consist only of antimatter, or universes in which matter, as we know it, does not exist at all. There could also be an exact double of our world. If our universe intersected or even partially overlapped with another universe in the early days, this interaction could leave traces in the cosmic background radiation. Scientists are now using the unique power of the James Webb Space Telescope to study extremely distant galaxies and structures that could lie in the cold spot. If the JWST detects unusual matter distributions, strange light patterns, or even signs of unknown physics there, it could be a strong indication that the cold spot was actually caused by interaction with an alien universe. 5. JWST confirms problem with the expansion of the universe. Further evidence of another universe? Did you know that it has been known for decades that the universe may not be expanding uniformly after all, as originally thought? This assumption goes hand in hand with the cosmological principle, which states that the universe is homogeneous and isotropic on a large scale. According to this, it should look the same everywhere and behave the same when observed on a physical scale. But the latest measurements cast doubt on this notion. There are indications that the universe is expanding at different speeds in different regions, which not only questions the standard model of cosmology, but could also point to some crazy other theories. The first idea is that our universe interacts with another universe and its movement is thus regionally distorted. The other idea is that we live in a bubble universe. Within individual bubbles, slightly different laws may apply, and therefore expansion within the bubbles is always slightly different. The different expansion was proven by discrepancies in the so-called Hubble constant, which indicates how fast the universe is expanding. Depending on the measurement method, different values were obtained in the past. While data from the Planck satellite indicate a slower expansion rate of 67 kilometers per megaparsec, measurements of supernovae yield a value of 73 kilometers per second per megaparsec. This so-called Hubble tension is one of the greatest unsolved mysteries in modern cosmology. The JWST was used immediately after its launch to retake the measurements. There was a small chance that the precursor telescopes were wrong, but that is not the case. The JWST confirmed the Hubble tension once again, leaving scientists even more baffled. Even more mysterious than the tension itself are regional differences in the expansion rate. Some observations suggest that certain areas of the universe are expanding faster or slower than others. If confirmed, this would be a disaster for the standard cosmological model. If it's confirmed that our universe is not affected uniformly everywhere, calculation and scientific exploration from a distance will be almost impossible. Researchers would have to abandon all goals of being able to decode the universe through formulas and theories. 6. Strangely bright objects in the early universe, a cosmic mystery. Imagine that researchers used the JWST to observe details of the early universe. Suddenly, extremely bright objects appeared where there shouldn't be much, and they only existed a few 100 million years after the Big Bang. These mysterious light sources are much brighter than should be possible for this epoch and present astronomers with another major problem. The spots appear too young, too massive, and too bright to be normal galaxies or stars. But what could they be then? One obvious explanation would be that they are early quasars. These would be supermassive black holes made to glow by huge amounts of accumulating matter. But here too, there is a problem. According to previous models, the formation of such gigantic black holes takes hundreds of millions of years, but some of these bright objects already existed 300 to 400 million years after the Big Bang. The question also remains for these objects. How could they accumulate such a mass in such a short time? Some researchers speculate that these could be a completely new type of celestial body, so-called dark stars, or pre-galactic objects, which are possibly relics of a previously unknown physics. Subscribe to the channel now. We are constantly publishing new exciting videos.